Hi guys, sorry we can't be together, but hopefully this video will do. Let's get started with a joke of the day, because I know you missed joke of the day. So, why should you never use a dull pencil? Because it's pointless. I just love these. Alright, one more. I know some people hate math, but you've got to admit, decimals have a point. Oh my gosh, this is good stuff. Okay, so let's get into the lesson. This is section 3.6, and remember this wraps up the entire chapter of 3. And what we're going to do in 3.6 is we're going to look at linear inequalities in two variables. We know how to graph a line in the 2D coordinate plane, but you know that in life you're not always going to have a situation where two things are equal to each other. Oftentimes one is bigger than the other, or one is smaller than the other. So we have to look at when that happens in the 2D coordinate plane, how do we handle it? First thing to understand is that the solution of a linear inequality in two variables is simply the ordered pair that when you substitute it into the inequality, it makes a true statement. Remember, we've talked about truth before. And let's say, for instance, we have this inequality here. What if it was an equation, and instead of the inequality symbol looked like this? Then remember, what we're doing here is we're looking at the idea of a balancing act. This is that fulcrum that's in the middle of the pan balance. This is in this pan, and then this is in the other pan. And when the two are equal to each other, your balancing act is done. So you have truth. But with an inequality, you're still looking at the idea of needing truth. You're saying, what will make this a true statement? So we're capitalizing on things that we already know. So if your ordered pair can be plugged in here, and you still come up with a true statement, then yes, that ordered pair will be a solution to that inequality. So I've got an example here. We've got this inequality y less than 3x minus 4. And what we're going to do is determine if this ordered pair is going to be a solution to that inequality. Well, if it is, then I should be able to take this ordered pair, plug it in here, and come up with a true statement. So let's try it out. What I'm going to do is I'm going to put the 4 in for the x and the 2 in for the y. So the y becomes 2. The x becomes 4. And now you know that when you look at a statement like this, you simply need to follow order of operations, which says I'm going to do this multiplication first, and 3 times 4 will give me a 12, and then 12 minus 4 will give me an 8. And then I simply look at that statement and say, well, is that true or is that false? Is 2 actually smaller than 8? Yeah, 2 is smaller than 8. That is a true statement. And when my statement is true, then that means, yes, that ordered pair is definitely going to be a solution to the inequality. So let's try this again. Let's test a different point. Let's try 0, 0, the origin of our 2D coordinate plane. If I plug that in here, will it make a true statement? So I'm going to do the very same thing. I'm going to take this 0, put it in here for y, take this 0, put it in here for x. So when I throw the 0 in for y and the 0 in for x, I've got a similar idea going on here that I need to follow my order of operations, which says, let's do this multiplication first. 3 times 0 is 0. And now 0 minus 4 is a negative 4. And once again, I look at that statement and I say, well, is that true or false? Is 0 in fact smaller than a negative 4? No, it definitely isn't. That is a false statement. So what that tells me about this ordered pair is that this ordered pair, when I plug it in here, it creates untruth, falseness, and so no, it cannot be a solution to that inequality. So that allows us to determine whether or not an ordered pair on the 2D coordinate plane will work. But you know that in that 2D coordinate plane there's all kinds of points, and we can graph lines in our 2D coordinate plane. So let's take a look at when we graph the line and it cuts that 2D coordinate plane in half, then what happens? So we're going to be graphing linear inequalities in two variables. And the steps are that first, we need to graph the line. Now when you graph that line and you put it in that 2D coordinate plane, The issue is that depending on whether or not you have an equal sign or a not equal sign, in other words, a straight inequality like this, or a greater than or equal to or less than or equal to, that will determine whether the points on the line are going to be solutions to the inequality. So we may need to designate that those points are included. We may need to designate that those points are not included. Go back to what we looked at when we were doing single number lines and we had inequalities on the single number line. Let's say, for instance, we had this point, and we said we want that 8 to be included in our solution set. If it was included, what did we use to designate that? That was a bracket. If it was not included, what did we use to designate that? That was a parentheses. Well, the catch is, on this 2D coordinate plane, it's not going to make any sense at all to put a bracket on this number line, or the line, and it makes no sense to put parentheses on there. So we have to have some other kind of designation to say whether that line itself is included in your solution set, or whether the line is not included in the solution set. So instead of brackets and parentheses, let's use solid and dotted lines. The solid line will designate, just like your bracket did, that your line is going to be included. And so the dotted line will designate that your line is not included in the solution set. And how do we know whether or not the line is included or not included? That comes from your inequality symbol. You know that if you have situations like this, you're greater than or less than, or greater than or equal to, or you're less than or equal to, those show that the line is included, and those points are on the line are included. The dotted line would come from your less than, your greater than, or your less than. The fact that there's no equal to part in here shows that the points on the line are not going to be included. So that allows you to graph the line on the 2D coordinate plane. But when you get the line in there, suddenly what happens is you've got two half planes. You've got a half plane up here, you've got a half plane down here. Now each half plane might contain all the solutions or might not contain all the solutions. So we've got to figure out, how do we find which half plane has all the solutions? You can do what we just did. Remember in the example we just had before, we took a point, we tested it in there, and we said, in the inequality that is, and we said, does it create a true statement? If it did, it's included, it's a solution. If it created a false statement, it's not included, it's not a solution. So that's what we're going to do. We're going to test a point, just like we had done. But notice I can pick any point that I want on that 2D coordinate plane. Folks, make your job easy. Which of the points on this 2D coordinate plane would be the easiest point to plug back in there? If you go back and review the example that we had just done, remember that point 0, 0 was super easy to use, because 0 times anything is 0, 0 divided by anything is 0, 0 plus anything is itself, 0 minus anything is itself. So if you can pick 0, 0, definitely pick it. Now you won't always be able to, but if you can, choose 0, 0, because it's easy to work with. So like we said, when you plug it in, if you come up with a true statement, once you plug that number into your inequality, that means that ordered pair is a part of the solution. And so let's say we pick this 0, 0, let's say it makes a true statement, then that means this one works, but it means everything else over here works as well. So how am I going to show the things that work? Remember, when we did a single number line and we wanted to show everything that worked, how did we do it? Yeah, we shaded the things that worked. You're going to do the same thing here. You're going to shade the things that work. So when you come up with a true statement, you will shade that side that point that you tested is contained in. So true statement, shade that side. If you come up with a false statement, let's say I test that 0, 0, I put it into the inequality, just like we had done in the previous example, we came up with a false statement. Remember, that meant that this 0, 0 was not a solution, but that means everything on this side is also not a solution. That indicates everything on the other side is going to be a solution. So if you come up with a false statement, you simply shade the other side. And that, my friends, is how you graph a linear inequality in two variables in the 2D coordinate plane. So let's try some examples and put it into play and see how it actually works. I've got several examples here, and in each example we are going to graph the inequality in the rectangular coordinate system. Remember, rectangular coordinate system, Cartesian coordinate plane, 2D coordinate plane, it's all the same thing. Let's go with the one we looked at before, the y less than 3x minus 4. Now I can graph y less than 3x minus 4 in the 2D coordinate plane, but remember when I graph it as a line, that's an equation. And inequality is the idea of the shading, but the line is represented by an equation. So I'm going to turn this into an equation so that I can put it in the 2D coordinate plane. Now when I do, notice that this is in that slope-intercept form. Slope-intercept, remember, was your y equals mx plus b. And when the y is by itself, you can pull out the slope, and you can pull out that y-intercept. And remember, the slope is a counting tool, but you have to have a place to count from. So put your y-intercept on there first. Then use your counting tool to get the second point on your line. Remember, it only takes 2 points to make a line. Here's your first one. When you count, that'll get the second one. So this y is by itself in that slope-intercept form. That means that my slope, the m, is going to be the number right in front of the x. That's 3. My y-intercept is going to be the -4. Since it is a point that's in the 2D coordinate plane, I'm going to put it in coordinate form, and any y-intercept on this axis right here has an x-coordinate of 0 because I've not moved left or right at all. So the x-coordinate is 0 and the y-coordinate is -4. So I can graph that line by putting that 0, -4 on there, and then from there using this slope. Now remember, it's a counting tool, rise over run. Right now I've only got one number, so I need to turn it into a fraction, but that's easy. I'm just simply going to put it over top of a 1. So my rise is 3. That means from here, because it's positive, go up 1, 2, 3. My run is also positive, and that's the horizontal change. So that means I'm going to go to the right. So I go up 1, 2, 3, and go to the right 1. There's the second point that it takes to make that line. Now me, I get excited and I start drawing my line. But I need to slow myself down because I need to determine whether or not the points on that line are included. And I need to designate that with either a dotted line or a solid line. So remember, how do you determine whether or not they're included? Yes, you go back and you look at that inequality symbol. There is no equal to part here. If there's no equal to part, then that means that the points on this line are not included. The way that I show that is by using a dotted line. So I'm going to drop my dotted line through here like this. Now my line is graphed. But if you recall, there's a second part to this because now it's an inequality. And when an inequality, that means that maybe these up here will work or maybe these down here will work. And I've got to figure out which side has all those solutions. So what I'm going to do is I'm going to pick a point that's in one of those half planes and I'm going to test it in the inequality to see if I come up with a true statement or not. Remember, if you can pick 0, 0, do, because that is so easy to work with. 0, 0 is not on the line. The times that you cannot pick 0, 0 are when they are actually on the line, because then that just tells you what's happening on the line. I want to know what's happening in a half plane. So the fact that 0, 0 is not on the line, it's in a half plane, means, yeah, I can use it. So I'm going to take that 0, 0, and I'm going to test it in my inequality. I'm going to take this inequality right here. I'm going to put a 0 where the y is, put a 0 in the x is, just like we had done in that first example. And remember, in the first example, this entire side became a -4. This side's a 0. And we look at that statement and say, is it true or is it false? Is 0, in fact, less than, smaller than a -4? No, it's not. This is a false statement. And remember, when it's false, then that means this 0, 0 is not a solution. It won't work. But that also means everything else over here is not a solution. So where are the solutions then? Sure, they're on the other side. So I'm going to shade this side to say that's where all the solutions are. And that is your graph of that linear inequality in two variables. So let's try another one, because it can get a little bit harder. And this time, let's try this one. 2x plus 5y, and it's going to be greater than or equal to 10. Now remember, the first thing that I have to do is I have to graph this as if it was an equation. I need to graph the line that would go with this. So if I would look at it as an equal sign instead of an inequality symbol, that will allow me to graph the line. Now remember, there's several ways to graph the line. Sure, we can use that slope and that y-intercept, and I can take this and I can get the y by itself. When I do, then I'm going to be able to pull out the number in front of the x, that'll be my slope, and I can pull out the number that's been added or subtracted, that'll be the y-intercept. But we also have the tool of the x-intercepts and y-intercepts. So just to kind of practice it a little bit, I'm going to try that out. I'm going to get an x-intercept first, but remember, how do you get an x-intercept? Yeah, you make the y 0. So I'm going to take this equation right here, and I'm going to put a 0 right here where this y is. Remember, this entire term will be gone because 5 times 0 is 0. And I'm just left with 2x equals 10. Then I'm going to divide through by 2, and 10 divided by 2 is 5. That gives me the x-intercept for that line. Now remember, it's a point on the 2D coordinate plane, so I'm going to put it in coordinate form. The x is 5, and when the x is 5, the y is 0, because I made the y 0. So that gives me the point 5, 0. But I need a second point on that line. So now I'm going to get my y-intercept. And remember, to get a y-intercept, all I have to do is make the x 0. So I'm going to take this equation, I'm going to make this x right here 0. And remember, this is totally gone because 2 times 0 is 0. I'm simply left with a 5y equal to a 10, and then I go through and I divide by 5. There's my y-intercept. Remembering that that is a point on the 2D coordinate plane, I'm going to put it in coordinate form. The x is 0 because I made it 0, and the y is a 2. There's the second point on that line. And again, before I get trigger happy and draw that line, I got to determine, is it solid or dotted? Are the points on the line included, or are the points on the line not included? Go back and look at your original inequality. The equal to sign means, yeah, they are included. To show that, I'm going to draw a solid line. But now all that does is graph an equation. But remember, it's an inequality. That means that one side of that 2D coordinate plane is going to have all the solutions. So I've got to figure out where they are. So once again, I'm going to look at this 2D coordinate plane, and I'm going to pick a point on one of the half planes. 0, 0 isn't a half plane, and we've already discussed it. Pick 0, 0 if you can, because life is so easy when you do that. So I'm going to test that 0, 0. And remember, I'm going to test it up here in the inequality. So I'm going to toss a 0 where the x is, toss a 0 in the y, and then I'm going to see, does this make a true statement? Well, this becomes 0, that becomes 0, 0 plus 0 is just a 0. Now, is that true or false? Is 0 in fact bigger than 10? Yeah, it's absolutely bigger than 10, so we have a true statement. And when we have a true statement, that means that this point 0, 0 is a solution, it'll work. But that also means every point over here will also work. To show that, I'm going to shade that entire side. And there you go. That's how you graph that one. One thing I want to point out is, remember that everything on the line is included. So that means any of these ordered pairs on that line, I could plug up in here and they would create a true statement. Now the points on that line, say for instance that 0, 2, if I put a 0 right here where this x is, I get a 0. If I put a 2 right here where this y is, I get a 10. So I have 0 plus 10, which is just a 10. Notice here that it says it's okay to be equal to 10. So in other words, everything on this line, because it is solid, will create the equal to part. Everything will work, yeah, but that's because of the equal to part. Everything down here will create the greater than part. So if this line was dotted, which it's not, but if it was, in other words, there was no equal to part here, then nothing on the line would work because everything on the line will create the equal to part. And if we did not have that in there, then that would be false. But like I said, that's not the case here. We definitely have an equal to part. We definitely need the solid line on this one because there's an equal to. All right, let's try another one. So this one looks like this. And remember in the last example I said you could get your X and your Y intercepts to graph it, but you could also rearrange it and get the Y by itself. Oftentimes it's easy to get the X and Y intercepts when, like for instance in the last one that looked like this. Oh, sorry, it was greater than or equal to. But the point is, if I can take this, remember, to get an x-intercept, I'm going to make the y 0, and that will be gone. So if I can look at this and say the 10 is easily divisible, cleanly, easily divisible by 2, then I can easily get that x-intercept. To get a y-intercept, I'll make this 0. That will be gone. So again, if I can look at this and say, well, when that's gone, this 10 is easily and cleanly divisible by 5, I can easily get a y-intercept. X and y-intercepts actually are a very easy way to get the 2 points that are on that line. So don't discredit getting X and Y intercepts if those numbers will divide evenly. But they won't always. Like say for instance if this was a 7, well if I knock this out by trying to get a Y intercept, 10 does not divide easily by 7. So I probably don't want to get X and Y intercepts in that case because here I'll get a fraction for that Y coordinate. And when I try to graph that on the 2D coordinate plane, I don't really want to try to have to graph a fraction if I don't have to. So that's a tip as to when it's best to get the X and Y intercepts and when it's best to take your equation and rearrange it. See in this one, if I would try to get the Y intercept and I would make, or sorry, the X intercept and I try to make this Y 0, 11 is not easily divisible by 4. So in this case I'm thinking, you know, I probably ought to just get that Y by itself. It'll be easiest that way. So to get the Y by itself, I'm going to subtract that 4X off. Remembering that the sign in front is the sign that goes, and actually I'm going to treat this like an equal sign now because I'm going to graph the line. So this is a negative 4x, and this is a positive 11. Now that the y is by itself, like we discussed before, I can get that slope and I can get that y-intercept. The slope is a negative 4. Because I know it's a counting tool, I'm going to put it over a 1 so that I can have the rise and the run. My y-intercept is 11, but because it's a point in the 2D coordinate plane, every coordinate on this y-axis, every ordered pair on the y-axis has an x-coordinate of 0. So now I know I'm going to start at 0, 11, right here. From there, my slope of negative 4, 1, most of us toss that negative up to the numerator, so I'll leave it up there. That means I'm going to come down 4. My rise is negative. That's the vertical change. So since it's negative, that means come down 1, 2, 3, 4. My run being positive means that I'm going to move to the right. That's your horizontal change, is your run. So it being positive, I'm going to go to the right. That lands me right here. There's the 2 points that it takes to make that line. Before I go trigger happy and start making the line, I need to look at the inequality symbol to determine if it's solid or dotted. There's no equal to part, so that tells me that it's going to be dotted. So there's the line. But remember, the fact that it's an inequality means that one of these half planes is going to have all the solutions. I've got to figure out which half plane has them. So again, pick a point that you can test. If you can pick 0, 0, 2, awesome, I can test 0, 0. So I'm going to take that 0, 0. I'm going to toss it back up into my inequality from the beginning, put a 0 here where the x is, put a 0 here where the y is, and follow the order of operations. That's a 0, that's a 0. When you add the 2, you get a 0. True or false? Is 0 in fact less than 11? Yeah, it is. That's a true statement. So that means this will work. It also means that everything on that side will work. So I'm going to shake the entire side. And that is a picture representation of all the solutions that will work. Remembering everything over here works, but everything on the line won't work because the points on the line, like say for instance this 0, 11 right here, when I plug it up in here and I put a 0 in that and 11 in here, that 0, 0 plus 11 is 11, that would be okay except there's no equal to part. So it's not okay for them to be equal. That's why everything on that line won't work. Same thing for this 0.17. Put a 1 up here, put a 7 up here. 4 times 1 is 4, plus a 7 is still 11. And again, the idea is there's no equal to part. It's not okay to be an 11. So that's how you graph that one. All right, let's try one more because this last one tends to be confusing to people. Kind of throws us for a bit of a loop. So in this one, because the numbers look like they will divide pretty evenly, not a bad idea to go with those X and Y intercepts. So I'm going to try that out, and I'm going to try to get my X intercept. What I'm going to do here is treat it like an equation because I'm going to graph the line. And so to get that X intercept, make it bigger so you can see it, that means I'm going to make the Y 0. So I'm going to put a 0 right here where this Y is. This becomes 0, I'm left with 2x equals 0. When I divide through by 2, x is 0 itself. So that is a point on the 2D coordinate plane. It is my x-intercept, and on that x-intercept, the x is 0 and the y is 0, right here at the origin. Now, some of you are sharper thinkers than me. You think outside the box really well. But me, I tend to be a little bit of a robot, so I'm going to just keep going through the motions, and I'm going to get my y-intercept. A lot of you are shaking your heads going, no, stop. Hang on, we'll get there. So I'm going to take that x, I'm going to toss it right in here. Remember, this becomes 0. I'm left with a negative 6y equal to 0. When I divide through by negative 6, I simply get a 0. And that's a point on the coordinate plane, so I'm going to put it in coordinate form. And my x is 0 and my y is 0. Here's why several of you are shaking your heads going, stop, you don't need to do this. Because you knew right here, that is my x-intercept, but it's also my y-intercept. Because on the y-intercept, that means make the x 0. So you knew immediately the x and y-intercepts are going to be the same point. So you didn't have to go through all this. But I'm just showing that if you don't think outside the box really well, and you just kind of become a robot and go through the motions, you'll get there. You'll just be a little bit slower like me, and that's all. But now the issue is, I only have 1 point, and I need 2 points to make a line. So where am I going to get that second point? I have a couple of options. One option is to go back to that point plotting method we had done a long time ago and say, let's just pick something for the x, toss it in here, see what spits out for the y. That'll create another point on this 2D coordinate plane, and I can graph it. The other option, remember, is I didn't necessarily have to go through the x and the y intercepts. I could have taken this, I could have gotten the y by itself to create that slope-intercept form. When I have slope-intercept form, that y-intercept will be 0, and I'll have the slope, which is my counting tool, to count from this point. So just to kind of continue with good practice, let's take this, rearrange it, get the y by itself. So when I do, what I'm going to do is take this 2x minus 6y equal to 0, and I'm going to subtract that 2x off. Remember, that leaves me with a negative 6y equal to a negative 2x, and then I'm going to go through and divide by a negative 6. Negative divided by negative is positive, and 2 6 reduces to 1/3. So now that y is by itself. Remember, that plus 0 back here indicates that your y-intercept is 0, 0, which we've already got here on the 2D coordinate plane. But the nice thing is now we've got this slope of 1/3, meaning from 0, 0, I'm going to go up 1, right 3. So when I go up 1 and right 3, that lands me here. There's the 2 points that it takes to make that line. I just need to determine, is it solid or dotted? There's an equal to part. So what does that indicate? Sure, it indicates it's going to be a solid line going right through there. And you know how I am. Pretend it's straight. I can't draw a straight line. Now, I've got 2 half planes. I've just got to figure out which side contains all the solutions. Can I test 0, 0, which is my favorite point? Can I test it? Not this time because it's on the line. I know that 0, 0, when I throw it up in here, it will create a true statement, but it won't tell me what's happening on the half plane. I need to pick a point that's out here or out here. Pick something that is clearly out there, something that's most definitely not on the line. Me, because I'm not that great with drawing straight lines, if I pick something like maybe a 1, 1, that might actually be on the line because I'm not that great at drawing a straight line. So me, I'm going to pick something sitting way out there. That 0, 4 is definitely not on that line. So I'm going to test my 0, 4. And again, if you can grab a 0, do, because it's very handy. I'm going to take that 0, 4, and I'm going to toss it right up here into the original inequality. So this x will become 0. This y will become 4. And I want to see if that's going to be greater than or equal to 0. Well, 2 times 0 is 0. Negative 6 times 4 is a negative 24. So I look at this statement and I say, is negative 24 greater than 0? Is negative 24 bigger than 0? Absolutely not. That is a false statement. And when it's false, then that means this point does not work. And that means none of the points up there are going to work, so everything that does work is going to be down here. So I'm going to shade that side. And then that is going to be the picture representation of everything that does work in that inequality, remembering that everything on the line will work because everything on the line will create a 0, but it's okay for it to be 0. So that's how you graph your linear inequalities in 2 variables in that rectangular coordinate system. And what we're going to do now is we're going to take a look at horizontal and vertical lines and see what happens there. Horizontal and vertical lines. The nice thing about horizontal and vertical lines is that you have the very same steps. In other words, you're going to graph the line, you're going to determine whether it's solid or dotted based on your inequality symbol. You're going to test a point in your inequality to see if you come up with a true statement. If it's true, shade that side. If it's false, shade the other side. It's the same steps. So let's take a look at a couple examples here. And in each of these, just like before, we're going to graph the inequality. In the rectangular coordinate system. And the first one that we're going to look at is going to be an x greater than a negative 4. So with x greater than negative 4, remember the first thing that I have to do is I have to graph it like a line, which would be an equal sign. We've looked at this before. That is going to be a situation where I say, okay, I'm going to read it in a different way. I'm going to read it instead of x equals 4, it's going to be x has to be a negative 4. So where is x negative 4? Yeah, that's over here on the left. But where else is x negative 4? X is negative 4 up here, up here, up here, up here, down here. All of these have x coordinates of negative 4. I really don't care what y is, because I don't have a y in there. I just want to guarantee that that x is a negative 4, and that's all of these points. So now as I connect the line, I have to decide, is it solid or is it dotted? There's no equal to part here. So that means it's going to be a dotted line. Kind of like what I've got setting up here, just not that great of a dotted line. But now I've got to figure out which side has all the solutions. Before what we did was we said, let's test that 0, 0 if we can. Can I pick 0, 0? Sure, it's not on the line. So I'm going to test 0, 0. Now notice there's no y coordinate here. So I can't throw that 0 in the y. That's okay. Just make sure I toss the 0 in for the x. And so this becomes my statement. And it says 0 greater than a negative 4. Is 0 bigger than negative 4? Yeah, absolutely. That is a true statement. And remember what that means is this is a solution and everything on that side is a solution. So I'm going to shade this whole side over here. And that's how you graph that. Pretty easily done. Now let's take a look at another example. This time let's do this one. And I'm going to do the very same thing here. I'm going to treat it like an equal sign, treat it like an equation. And I'm going to graph that on the 2D coordinate plane, y equals 5. Now when I do, just like the other one, instead of reading it as y equals 5, I'm going to read it as y has to be 5. Where is y5? Up here. Where else is y5? That's over here, over here, over here, over here, back here. All of these are the points whose y coordinates are 5. I don't care what x is because I don't have an x. Just make sure that that y is a 5. So that's going to generate that horizontal line. But before I draw it, because I'm dealing with inequalities, I need to decide is it solid or dotted. There's an equal to part. So that means it's going to be a solid line, one like this. And now, again, I've got half planes, and I just need to decide which half plane has all the solutions because it's an inequality. So, can I pick my favorite point? Sure, 0, 0 is not on the line, so I'm going to test that 0, 0. And I'll toss it up in here. Just like before, there's no x in there to toss that 0 in. That's okay. So I'm not going to bother with it. I'm just going to make that y 0. And noticing that that is a true statement 0, yeah, it is smaller than 5. And so because it's true, that means this will work and everything down there with it will work, and I'm going to shade that side. And so that's how you do it. Now, notice, let me put this back up here so I can make an illustration. Notice that what we did here was the same steps as what we had done before, because it's nice when you can do the same old stuff before and you don't have to change processes, you don't have to change rules. So that's why I did it this way. However, there's another way to go about this, and if this makes more sense to you, then go with it. In this particular situation, it said I want all the x's that are bigger than -4. Well, as I look at this 2D coordinate plane, here's x -4, and as I look at the x-axis, where are the x's that are bigger than that -4? It's all of these. So that indicates everything over here is going to work because all of these ordered pairs are the ones that have x's that are bigger than -4. Same idea over here. This says I just want all the y's that are smaller than 5. Well, here's where the y is 5, and on this y-axis, all the y's that are smaller than 5 are down here. So all of these points are the points that have y coordinates that are smaller than 5. So you don't necessarily have to do the testing of the point. You can just take a look at the inequality and understand what it means and go with that. But if you're one who doesn't like changing methods and processes, then you can see that that old process of testing the point still works, and you can go with that. So that's how you graph your horizontal and vertical lines. So we're going to take a look now at some applications, because otherwise this is kind of theoretical, and as I keep saying, only entertains me. So let's see why we're bothering with this, and what's the point. Just like that pencil has a point, this has a point. So the application, I have a couple here. In each one of them, what we're going to do is we're going to write the inequality to represent the situation. And then we're going to graph the inequality in both examples. So my first example says that we've got a performance hall, maybe a concert hall, maybe a theater. But we're going to have a performance, and we're going to sell two types of tickets. We're going to sell adult tickets, and we're going to sell the adult tickets for $5. And we're going to sell children's tickets for $3. And so we want to know what's it going to take to make a profit, because that's why we're in business, to make a profit. It's a profit deal. So to make a profit, we need at least $2,000 to be collected. All the expenses that we've got into this designate that we need to collect $2,000 in order to make a profit. So there's our situation, and you know that when you attack a word problem, you need to read it in its entirety to figure out what's happening, and then take it sentence by sentence. So we've read it in its entirety. Now I'm going to break it down sentence by sentence. So first off, we know we're selling adult tickets. Do we know how many adult tickets? No, we don't. So we need a variable to stand for that. So let's let A equal the number of adult tickets sold. But what I do know is that when I take that A and I take the number of adult tickets, they're going to be $5 each. So if I have a number of tickets sold at $5 each, how would I represent the amount of money that I'm going to collect off of all of these adult tickets? That would be a 5A. Now, there's another situation in here. There's two types of tickets. There's adult tickets and there's children's tickets. Do I know how many children's tickets are being sold? No. So let's get a variable for that. And let's let C equal the number of children's tickets sold. And just like with the adult tickets, now I know that each children's ticket is selling for $3. If I'm selling this many children's tickets at $3 each, how would I represent all the money that I'm collecting off of children's tickets? That would be 3C. Now, I've got a pile of money here with the adult tickets, 5A. I've got a pile of money here with the children's tickets, 3C. These two piles of money, what am I going to do with them? Sure, I'm going to take the two piles of money and I'm going to put them together. Putting together indicates that I'm going to add the two piles of money up. Now, when I add the two piles of money up, what do I need to happen? Well, it says that to make a profit, at least $2,000 needs to be collected. So somehow, some way, this has to compare to $2,000. But the catch is it okay for this amount of money to be smaller than $2,000? Well, no, not if it says at least. It's got to be bigger than $2,000. But is it okay for it to be $2,000? Sure, that's what at least indicates. It says, oh, it's okay to be $2,000, and it's definitely okay to be bigger than $2,000. So there's the inequality that represents that situation. That's the hard part. Now the easy part is to be able to graph it. So like we said, what we're going to do is we're going to treat it like an equation, and we're going to graph the line that's represented by that equation. And there's a couple of ways of handling it. We can get X and Y intercepts, in this case A and C intercepts, or we can get the slope and the Y intercept, either way you want to do it. So what I'm going to do here is I'm going to just go ahead and try to get the X and Y intercepts. So to get that A intercept, I'm going to make the C 0. So I'm going to make that 0, and when I do, I have 5A plus 3 times 0 equal to 2,000. That entire term is gone, and so I have 5A equal to 2,000. And when I divide through by 5, my A is simply going to be 400. And since that's a point on the 2D coordinate plane, I'm going to let my A be like the X. So this would be like an X-intercept. So it would be 400, 0. And that's one of the points on the 2D coordinate plane. Now when I go to get the other point on the 2D coordinate plane, we'll call it the C-intercept, acting like a Y-intercept. That means make the A 0. So I'm going to take this equation, I'm going to throw a 0 where the A is. And now that means this term is gone. I'm left with 3C equal to 2,000. And when I divide through by C, 2,000 divided by 3 is actually going to be 666 and 2/3. The 6 is going to repeat, and that indicates 2/3. And again, that's a point on the 2D coordinate plane. The A is acting like an X, and I made it 0. The C is acting like a Y, and I got a 666 and 2/3. So there's the second point on the 2D coordinate plane. So now I'm going to go graph these 2 points. Now, usually on the 2D coordinate plane, I would do it like this. And this would be my x-axis and the a-axis, and this would be my c-axis. Now this a-axis, remember, it's representing adult tickets. Does it make sense to have negative adult tickets? No, it certainly doesn't. So I don't need this end of the 2D coordinate plane. This C is representing children's tickets. Does it make sense to have negative children's tickets? No, it certainly doesn't. So I only need the first quadrant of the 2D coordinate plane. I'm going to make it a little bit bigger now so we can see it. And this is my C-axis, and this is my A-axis. Now, my A intercept is 400, 0. Normally, I would make each one of these 1, but that's not going to work out really well to put a 400 on there. So I think instead I'll call them each 100. So this is 200, here's 400, and 600, and so on. So my point 400, 0 is going to sit right here. Now, my y-intercept, again, each one of these would be a 1, but because of the units that I'm using, I think it'd be better off to make each one of them 200 again, or sorry, 100 again. I'm going to go up a little bit higher so I can see better what's happening. And here's my 800. So 666 and 2/3, well here is 700, so 650 would be halfway. I'm going to go a little bit above halfway. There's my 666 and 2/3. Here's the 2 points that it takes to make that line. I'm ready to connect the line, but I need to decide is it solid or dotted. This tells me that it's going to be solid. Now remember though, this is an inequality. So I need to figure out which side has all the solutions. So I'm going to pick a point if I can. Can I pick my favorite point 0, 0? I sure can, so I'm going to pick it. So I'm going to test that 0, 0 because it is in a half plane. And I'm going to toss it into this inequality right here. So I'm going to make the A 0. I'm going to make the C 0 greater than or equal to 2,000. I think that's a little bit clearer. Now remember, this becomes 0, this becomes 0, 0 plus 0. The whole thing is 0. That's the beauty of 0, 0 if you can. So now this says 0 greater than or equal to 2,000. Well, is 0 greater than or equal to 2,000? No, that is definitely a false statement. And remember, when it's false, that means this doesn't work. Nothing over here works. Everything that does work is on the other side. So I'm going to shade this side because that shows where all the solutions are. And so this is a picture representation of everything that will work that will allow us to make a profit. Remembering that everything up here that's shaded in green, these are the children ticket and adult ticket combinations that will work. If I choose to, let's say I want to sell 800 adult tickets and 200 children's tickets right here, I'll make a profit. That will be okay. If I want to sell 400 adult tickets and 500 children's tickets, that will work, I'll make a profit. But if I want to sell 100 adult tickets and 200 children's tickets, I will not make a profit. And anything on the line actually is where you will break even. If I want to sell 400 adult tickets and no children's tickets at all, well, 400 adult tickets here will give me exactly $2,000 and no children's tickets, I will make exactly what I need to make, it's $2,000. So I will break even on that point. The profit is actually up here in the green area, and the line is the break-even point, and down here is no profit at all. So that's one example of an application of your linear inequalities and how to use them. So let's take a look at one more. And I'm going to erase the directions on this because I think we know what we need to do now. And so we need to write the inequality to represent the situation, and then we're going to graph it. And this will be the last thing we do out of this section. We'll wrap it all up. So in this one, we've got a guy, Henry, and he plans to buy X number of 25-cent stamps. Clearly an old problem, but that's okay. And, sorry, that's not the end of the sentence, and he wants to buy Y number of 20-cent stamps. So he has $7.50 to spend. But he doesn't need to spend all of it. So we need to write an inequality to represent the situation and then graph it. So we've read it in its entirety. We know that he's buying two different types of stamps, and now we're going to take it sentence by sentence. So the first type of stamp, I don't know how many he's buying. I'm calling it X. but I do know that each of those is worth 25 cents. I know that this is all the money that he has to spend, so if he buys X number of 25-cent stamps, then how much is he going to spend on just those stamps and those stamps alone? Well, it's going to be 25X. The problem that we're having here is, do I need to call it 25 or do I need to call it 0.25? It depends on how you want to handle your $7.50. If you want to retain the decimal here, then these 25-cent stamps need to be 0.25. However, if you want to call it simply 25, that's okay, but call this 750. So either way you want to go about it. I'm just going to go ahead and leave it as normal dollar-cent notation. Now, that's what he's going to spend off of these 25-cent stamps. He's got the 20-cent stamps that he's buying. How many? We don't know. It's this many. But how much will he spend off of all of them? It'll be Y times the 20 cents right here. So here's the amount of money he's going to spend on the 25-cent stamps. Here's the amount of money he's going to spend on the 20-cent stamps. But we know that he's spending all of that together, and so the together concept is going to be the idea of adding the two. But it says he has $7.50 to spend. He doesn't need to spend all of it, but he's allowed to spend up to that much. The idea up to that much means that when I put all this together and I compare it to this $7.50, can this be smaller than $7.50? Sure, absolutely. Can it be bigger than $7.50? Can it go this way? No, definitely not. It can't be bigger than that because that's all the money he's got to spend. So my inequality symbol definitely has to go like this. Is it okay for him to spend $7.50? Yeah, he's allowed to spend that much, so it's okay for it to be equal to. So you've just done the hard part. You've set up the inequality. Now all we got to do is put it on the 2D coordinate plane. So what I'm going to do is I can either get the y by itself or I can do my x and y intercepts. And it's looking like x and y intercepts will actually be pretty easy because I think I can take 750 and divide it by 0.25. I think I can take 750 and divide it by 0.20. So I'll do that. I'll get my x-intercept first by making the y 0. And that means I'm going to toss a 0 right here. Treating it like an equation because I'm graphing the line right now. This entire term will be gone, and I'll be left with 0.25x equal to 750. And then when I go through and divide by 0.25, 750 divided by 0.25 will be 30. So there's a point on the 2D coordinate plane. The x is 0, the x is 30, and the y is 0. Now I just need to go through and get that y-intercept. And when I get a y-intercept, I make the x 0. So I'm going to toss a 0 right here where the x is. Less than or equal, no, sorry, not less than or equal to 750. So like we said, this entire front term is gone. I'm left with 0.20y equal to 750. Oops, need that decimal point in there. And when I take 750 and divide it by 0.20, I will get 37.5. So my ordered pair will be x is 0 because I made it 0, and when I did, the y came out as 37.5. There's the second point on that 2D coordinate plane. So now when I go to put it on the 2D coordinate plane, like we've stated before, normally, if it was a theoretical situation, I would have the 4 quadrants. But this x-axis here is representing the number of stamps, and it doesn't make any sense to have negative stamps. This y-axis is representing also a number of stamps, and it doesn't make any sense to have a negative number of stamps. So just like before, I only want the first quadrant of that 2D coordinate plane. So let's make it a little bit bigger so we can see it. And x again represents the 25-cent stamps. I'm going to have 30 of them, so let's make each of these make each one of them 5, 10, 15, 20, 25, 30, 35, 40, and so on. So here's my 30, 0. And I'll do the same thing on this y-axis, make each one of them worth 5. And I come up with a 0, 37.5. Well, here's 30, here's 35, so 37.5 will be about halfway up. Now, I'm ready to connect them, but is it solid or is it dotted? There's an equal to part, so it's going to be solid. Ugh, pretend like that's straight, that's terrible. Cannot draw a straight line. There we go. Now, the fact that it's an inequality means I need to determine which side to shade. So I'm going to do what I did before, and I'm going to test a point. Can I pick my favorite point? Yes, I love it when I can pick 0, 0. So I'm going to test that 0, 0 to see if it works. I'm going to toss it up here into the original inequality. So my 0.25 times 0 plus my 0.20 times 0 needs to be less than or equal to my 750. This becomes 0, that becomes 0. When I take a 0 plus another 0, the whole thing is 0, less than or equal to 750. Is that a true statement? Yeah, absolutely. 0 is less than 750. So that means this works, and everything else on that side works. So I'm going to shade the whole thing. There we go. These are all the number combinations of 25-cent stamps and 20-cent stamps that he can purchase and not go over his $7.50 budget. Everything out here, he would go over his budget. Everything on the line would meet his budget exactly. One thing I want to point out, I think we talked about it before, but I want to make sure you understand is, normally, remember, I would put arrows on this line showing that it goes on forever. But this one's not going on forever, because if it went on forever this way, I would get down into negative 20-cent stamps. If it went forever this way, I would get into negative 25-cent stamps. And we already discussed you can't get into the negatives with numbers of stamps. So this line is not going to go on forever, and it's actually going to stop here and stop here. Also, normally when I shade, I would just shade like crazy through here, but I'm only shading within this figure because, again, shading down here would indicate negative stamps, shading over here would indicate negative stamps. That's not happening. So I'm going to contain my shading within that little triangle. But that's how you graph a linear inequality in 2 variables. And here's the applications of it. You can see there's lots of value to being able to do this, because this picture representation really helps a lot when you're trying to figure out what kind of combinations you can make.